proceed with the making of a test rule. We'll use this rule for the understanding of the rules language, and then at the end of this tutorial we'll trash it. Let's open the catalog tutorial under the archetypes with the archetypes model. Inside the archetypes model, we already find the test item that is installed from the creation. Inserting the test item, we have linked item 001 to a rule. This rule has been written by a default rule. Here we may see the group's definition. And the group's definition here is practically listed all of the questions that the program must ask. The questions are of several type. Opening the questions we may set: variant, fixed value, shape, group, add-on, multiple selection, free type variant dimension, variant C, no or no C. The difference is pertaining to the set default. Hidden variants, variants which allows you to write selections on SQL, separators, and other things. Actually, a group is a grouping of other variants. In this case, a variant exists that is called color, which is reported on the basic group. It's possible to intervene, entering inside a variant and selecting here a line and pressing the button variants. Each variant has a header on which we may write some information, a code and description, a default value, flags which show if the variant is of the managerial type, which means that it will be memorized in the ERP, if it should be shown in the language, if it's not a mandatory variant. Here in this case, when the variant is opened, it will be necessarily requested a value. If the variant must be memorized as part of the article or as a default, this means that some variants are proposed to be memorized in the article. Their final behavior is required to specialize a rule towards a different behavior on a different article. In detail, a variant is made by a series of lines. It's possible to write the lines in a pretty simple way. Here we are using a numeric type encoding since it's written this way. Every variant may have several contents. For example, at this point we create the variant wood. To the wood value we associate, for example, material number 4. It's possible to see the list of the material from here. Here we may link the variant to the material 2, genetic wood, and then specialize it. We can obviously create other types of materials. For example, the glass doesn't exist. Therefore, we should create a new material. Let's assume for the glass material number 7 and 8. And then we will define it. We have substituted the material pertinent to the glass with a color which better represents the glass. At this point, we try to understand why a box has been designed here with the dimensions expected for the article. Changing the dimensions also changes the article. This is because entering into the rule, the keyboard shortcut is Control plus G to enter into the graphic and Control R to enter into the rule. We access the graphic where we see that 001 is recalled with Control M. And we may see that 001 corresponds to a topology that we have named test, which already has a series of settings inside it. The settings are a description, a code that we will see be needed to eventually manage the topology as the special article, the variants, the comments, information required to specialize the article, possible graphic references, and much more information. Let's concentrate on the dimensions. On these dimensions is written that the element position must be 0, 0, 0. It refers to the origin in respect to the box initial coordinates, left, bottom, and back. The dimensions are linked to the formulas. We recognize the formulas because they begin with dollar sign. The variable's common setting is dollar sign, open parenthesis, name, underslash, variable, close parenthesis, or dollar sign, name, underslash, variable. The program defines and automatic some variables which therefore are always present. For the dimensions, dollar sign $L width, dollar sign $A height, and dollar sign $P depth. For the colors, for example, here it has been written a formula that means take the color as the third column of the color field. We write dollar sign, open parenthesis, color, column 3, close parenthesis. The pipe symbol is required to specify the eventual bitmap associated to this color. On our example, we provide the bitmap, which we should have written in dollar sign, in parenthesis, color, column 4. The result of this writing is this. Let's try to modify this rule. For example, let's copy the topology, creating two topology test instances. On the first one, we set the length equal to 20. On the second, we write SL equal dollar sign $L minus 20, and I equals 20. By doing so, we have created two different elements on which the length is 20 and are positioned one on the left and one on the right of the box. When we access to this interface, we can clearly see the dimensions and footprint of the box. Let's examine in depth this concept because we want to create a box now. Let's go back to the rule. On the interface, Control H allows to access to the typology. Every entry inside the topology may be specialized or directly modified this way, or from the user's interface, as we have previously seen, or by recalling Control H, inserting the corresponding position value. At the beginning, this method will be used, but when the program is better known, it will be easier to use this method. Indeed, by modifying the interface, we have exactly the same result. We may also use another copy of the test typology, and we specialize it this way. Now it's coming. Position 20, height 0, depth 0, and dimension L40, height 20, and depth dollar sign $P. Obviously, the required fields have already been discarded. Remember that we have set depth dollar sign $P, but the program has inherited the topology depth. We may do the same thing for what is concerned to the other element, which we'll put over here. Let's just position it as SA equal dollar sign $A minus 20. This way we obtain our reference box. Let's position a back inside this box using the same typology. Here we have inserted each single item. We could also insert a different color for this element. Let's write CL equal 1, fix. For example, in this case, the back will always be white. Therefore, changing the material, we have an article made out of 5 elements. 2 sides, a bottom, and a top, and a back. Changing the dimensions, the program adapts to it. Changing the depth, it adapts to the depth, and so on. Now we make sure there is a variable number of elements linked to the fact I want the presence of internal shelves. Therefore, let's enter the rule, define a new C-null variable, name it RIP, do you want shelves? This here setting generates a question which we see here. Now we make the answer to this question work. Let's create a shelf. Let's see if it works. We have positioned a central shelf on the element. Now we want the shelf to appear only if this flag is active. The flag is tied to the variant RIP. Therefore, we write in the rule if $ RIP column 0 equals 1, insert element. And here we enter into the main characteristics of the language. Selecting the element will see it, and not selecting it, it won't be there. We may widen this concept in endless ways, but before, let's go on in detail to understand some things. The variables are shown with the $ and are even highlighted in red in the editor. Usually the variables are $x, or in this form, or in this other form, open parenthesis x, close parenthesis. Flux control is done through the instructions. All the instructions begin with the pound key at the beginning of the line and are a series of instructions which allows to control the program. The most used ones are the ones pertaining to the if and if or se finesse cycle, and those about the for or other elements. Now let's do a different thing on the element. Let's transform what we have just created in a macro. To create a macro means to create a function that can be reused every time to do the same things. Therefore, we select the content of this function and write on the macro. Control H, we see the editor empty. Control M on the macro has created a new macro, which is named macro. Let's insert inside the macro the lines of the script previously created and verify that the rules behavior hasn't changed. We can clarify the importance of the macros used with the second example. We may write a equal $a/2. We verify the transfer of parameters to the macro. And we also write a second instance with other parameters. This has created two copies of the design's entire box, having processed two instances of the macro. The potentiality of the macro is enormous since it allows to nest elements in respect to each other. It's also interesting to see how under the tab detail, we see that the item in hand is made of a list of typologies. Today, the typology used is always the same, test typology. Normally, this is not a good work method because a typology should be defined based on the item's function. In this case, I should have written the typology for the sides. It doesn't matter for right or left. A typology for the shelves. It doesn't matter for bottom or top, but it's important whether they are structural or not. A typology for the backs. And this is a general representation of a box. We may even play around with this. Let's see, for example, some modifications of the rule. The question at this point is, have we brought the situation back to the initial form? It's because the 001 typology designs a parallel pipe. This is in reality due to the fact that when we have inserted the 001 typology, we have used one of the implied functions named lato. The program's implied function allow to draw different things with different features. The side is the program's standard function. Besides the standard function, it's possible to create new functions for the typology. The creation of an XP file is required in order to do this. What's a XP file? It's a service file which is required to link the 3D CAD typology. Let's write, for example, a column test and the rule to prove it. Pressing Ctrl H, the program says that it doesn't exist and requests to create it. In this case, we see an empty function with the typology and a series of features. Now let's see how it's used. This script copies exactly whatever the finish 0 does. That is, it defines a color that goes to read from the color 1 typology, and it draws a panel using the function WR panelo 2 with dimensions DL, DA, DP, with the same color repeated 6 times because it's different for each face. Let's see how to modify this function. We have created a second color in this case, not starting from the panel parameters, but from 200 color, specializing it with RGB 255, that is with a red color. We have applied a second color to the same facades. When we write the help function, it would help to understand what to assign to each single parameter. We have used this to obtain this result. At this point, the result is this. This means that if I change the material, this will be applied exclusively to some sides of the parallel pipe. For now, this doesn't work. This because the script isn't linked to the typology, and therefore we'll go on to link it. What we need to do is to comment the line of the test function and insert inside the typology the parameter GL equals text.xp. Actually, we could have written in full the complete path, but it's not necessary because this is the normal work path. The result now is that it's in steel, and it's modified this way. If I put wood, it's modified this way. At this point, to modify the function again, we use the commented function. It's interesting to note that the Control M button always works even on the commented parts. This makes it easier to modify or to research an existing rule. We see this little longer version in which we have made the entire box using some transformations of the panels. The instruction is WR transforma that must be followed by WRQD and recalling up the panels where needed. The result of this operation using only one typology is a box. Let's see the result of this alternative management. Let's give attention to the fact that in detail we will find anyway only one test typology. Therefore, having to develop a bill of material or other things, the program will see the element as a whole, and therefore it won't be able to divide it unless using some of the typology's parameters. Let's consider this last one as an exercise. To complete the script, let's see how we pass a genetic parameter to the typology. The genetic parameters are the X parameters from 1 to 9, and they may contain values on more columns as long as they are separated by a bar. In this case, we have passed a single value, which is the value of the variant Voi Ripiani. We have used in the script the control of this if the parameter 8 is worth 1. Also insert the center panel. The result is evident. Voi Ripiani, non Voi Ripiani. Therefore, using the same typology, we create a rule. Summarizing what we have learned, the XP extensions are written in the VB script language. These are required to link the CAD 3D with the typology. We practically have here the operations detail. A basic list of functions is available for the drawing. To learn these functions is not easy, and there are many of them. These scripts substantially allow to completely create the program's graphic. It could be useful to retrieve a few from the 3ds/script folder and try to understand and modify them. It depends on what you want to obtain, to use a complex script like this one or to use a set of typologies. If we want to obtain a bill of material and want to ease the effort for the job, it would be convenient to manage a macro and not a script. If instead you want to simplify the writing of the rule, lowering the complexity of the drawing, it would be convenient to use this method. It's also possible to mix the two systems. We will not do it in this tutorial, but it may be an interesting exercise that we advise to try out. It's not always necessary to specialize the information on the line, but often it would be enough to specialize them in the typology. That is to write in the typology $, rip column 0, and in this case GL equals test dot xp. This means that every time that I use this typology, it would practically be the default settings used in this typology. They will disappear from here and the result doesn't change. Let's see some other scripts modification. This one in particular looks particularly interesting because it's about the movements. We have created a movement sequence for the panel to make it there are more elegant forms. Just look at the scripts already present inside the catalog. The one shown here is essential. We have created a transformation resetting the timer starting from 0, 0, 0 position. Then after 1500 milliseconds we take the panel to the 0, 0, 300 position. After another 1500 milliseconds we go to the 0, 0, 300 position but with a 90-degree rotation angle. Let's remember to close the transformation because the transformation with the timer is equal to W transforma. Let's see the result. When we activate and touch the shelf at first comes forward and then it rotates and closes. These movement sequences are useful to open doors or to show the mechanism operation inside the catalog. We will create in the tutorial the scripts as they are needed. We advise to carefully design the scripts so to reuse them on different catalogs. This section was useful to understand how to create the rule, how to approach the rule, and therefore to have a better idea on the making of the rules for the catalogs tutorial. Now, after a backup of this rule and of the catalog, which will be stored in the folder linked to the tutorial, we will start over from the situation prior to this lesson for the following one.
chiederti se lui, perché non ho sentito il commento. muoiono quelli, poi arrivano altri. Ciao.
No, non bisogna, no, non bisognerebbe che qualche pazzo che ha deciso di fare decidere che invece di Roma tirasse una bella bomba e mi tira giù tutto, capito? Che se resta mi pure la pensione di padre.
È vero, magari anche di validità.
Secondo me, no, ma no, così si tira giù.
No, non mi fanno una civile.
Sì, sì, vedrai. O forse sarà l'unica soluzione. Ma sì, finché non fanno qualcosa anche per gli altri. No, sempre così.
No,
Ma
no,
dove eri? Stati Uniti proprio?
sì.
Dove? New York?
Vicino a New York, New Jersey. Fai 40, come da qua a Treviso.
Che bello.
Eh.
Non sei stato tanti anni là tu, oltre a esserci nato.
Sì, sono stato alle fino, avevo 10 anni quando siamo venuti qua, siamo venuti qua. Poi
Come mai
dice,
dall'America all'Italia?
mia madre è proprio qui.
Ah,
È conosciuto mio padre. Cosa è successo?
ah, uno smontato il mio computer, vero? Che già ho capito che non mi arriverà più.
Ma cosa è successo qua?
È andato in stand by.
È successo qualcosa che non doveva succedere. Ah, eccolo qua.